Every GPS satellite above your head corrects its clock using Einstein's gravity, not Newton's. Without those corrections, your phone's location would drift by miles every day. That single fact reveals something profound. Gravity may not be a force at all. For over 300 years, gravity seemed settled science. Isaac Newton described it as a force, an invisible pull acting instantly across space, binding planets to stars and apples to Earth. His equations were elegant, predictive, and astonishingly accurate. Bridges stood, cannons fired true, and the solar system moved exactly as his math said it should. For everyday life, Newton's gravity still works flawlessly. Then Albert Einstein arrived and quietly overturned the entire idea. Einstein did not merely refine Newton's theory, he replaced its foundation. In his view, gravity is not a force pulling objects together. It is the result of space and time themselves bending. What we experience as gravity is motion along curved spacetime. The question is no longer academic. It reshaped physics, astronomy, and our understanding of reality. Newton's gravity, the force that rules the classical world. Newton defined gravity as an attractive force between any two masses. The larger the masses and the closer they are, the stronger the pull. This simple law explains falling objects, planetary orbits, tides, and even the trajectory of comets. Crucially, Newton's gravity acts at a distance. The Sun pulls Earth across empty space without anything physically connecting them. Newton himself found this unsettling, but the mathematics worked so well that the discomfort was ignored. For centuries, there was no reason to doubt it, until precision measurements exposed small cracks. Mercury's orbit did not behave exactly as Newton predicted. The discrepancy was tiny, but persistent. Classical gravity could not explain it without inventing unseen planets that did not exist. That anomaly opened the door for a deeper explanation. Einstein's gravity, geometry, not force. Einstein's general theory of relativity begins with a radical idea: space and time form a single fabric called spacetime. Massive objects do not pull on one another. Instead, they warp this fabric, and other objects move along the curved paths that result. A useful analogy is a stretched rubber sheet. Place a heavy ball in the center, and it creates a depression. A smaller ball rolling nearby will spiral inward, not because it is pulled by a force, but because it follows the curved surface. In Einstein's universe, Earth is not pulled toward the Sun. Earth is moving straight ahead through curved spacetime created by the Sun's mass. Gravity emerges from geometry. This explains phenomena Newton's theory cannot. The precise orbit of Mercury, gravitational time dilation, where clocks tick slower near massive objects. The bending of light around stars and galaxies. Gravitational waves rippling through spacetime itself. Every one of these predictions has been experimentally confirmed. Is gravity an illusion? Calling gravity an illusion is provocative but misleading. Gravity is not fake. Its effects are real and measurable. What is illusory is the idea that gravity is a traditional force like electromagnetism. When you stand on Earth, you feel your weight. But according to Einstein, that sensation does not come from gravity pulling you downward. It comes from the ground pushing you upward, preventing you from following your natural path through curved spacetime. In free fall, like astronauts orbiting Earth, you feel weightless, even though gravity is very much present. This flips intuition upside down. Free fall is not the absence of gravity, it is motion purely under gravity's influence. Why Newton still matters. If Einstein is correct, why does Newton still dominate engineering, aviation, and spaceflight calculations? Because spacetime curvature is usually weak. In low speeds and moderate gravity, Einstein's equations reduce almost perfectly to Newton's. Newton's gravity is an approximation, extremely accurate where spacetime is nearly flat. Einstein's theory becomes essential only in extreme conditions: black holes, neutron stars, GPS satellites, and the early universe. This is not a replacement, it is a hierarchy of understanding. The deeper implication: Einstein's gravity blurs the line between physics and geometry. Space is no longer a passive stage where events unfold. It participates. It bends, stretches, ripples, and evolves. Yet a mystery remains. Gravity does not fit cleanly with quantum mechanics, the theory governing particles and forces at the smallest scales. Every other force has a quantum description. Gravity resists one. This tension suggests that even Einstein's view may be incomplete. If gravity is geometry, what is spacetime made of at the deepest level? That question drives modern physics. If gravity is not a force but the shape of reality itself, what other forces might turn out to be something deeper? Subscribe for more science that challenges intuition and reveals how the universe truly works.